All right, we're going to get a little more practice here with simplifying complex fractions. And these are a couple of examples where we have a rational expression in either the numerator or denominator. In the second example, we have two rational expressions or two rational terms in the denominator. So when this is the case, it's easier to use that method of multiplying the numerator and denominator by 1, which includes whatever the LCD is of the little denominators, quote unquote. Okay, so in this first example of 2 plus 1 over x times 2x plus 1, the little denominator is just x, right? We've got the 1 over x there. The 2x plus 1 in the denominator doesn't have any fractions involved there, right? So we're really just concerned with looking at the only little denominator we have here is that x, right, that we want to get rid of. So I'm going to multiply the numerator by x and the denominator by x, right? I'm multiplying the whole fraction by 1, essentially, right? Okay, so now I've got to distribute that x through to both of those terms in the numerator. So I'm going to have 2x, and then 1 over x times x is just 1, right? And then down below, I could distribute the x through, but I think I'm going to leave it alone. And why is that? Well, we have a factor that cancels here, right? So we're left with 1 over x, right? And we canceled the 2x plus 1, which was in the denominator, right? So what makes that 0? Subtract 1 from both sides, divide both sides by 2. X is equal to negative 1/2, right? When we set that factor of 2x plus 1 equal to 0. So we'd have to say x can't be negative 1/2, right? That would be our hidden domain restriction. What about this second example? We've got 5 divided by 3 over x plus 4 over x plus 1. Okay, so I look at those little denominators of x and x plus 1, and the LCD is just going to be x times x plus 1, right? And we want to get rid of those denominators. So if we're multiplying the denominator by x times x plus 1, we also must do that to the numerator, right? Essentially multiplying the fraction by 1. Okay, so for the moment, I'm going to leave the numerator factored, 5x times x plus 1. And then in the denominator, we're going to distribute the x times x plus 1 through. So with the 3 over x, the x cancels, right? And I have 3 times x plus 1. And with the 4 over x plus 1, the x plus 1 will cancel, and I'm just left with 4x. Right? Leaving the numerator factored, I'm going to combine like terms in the denominator. Looks like I have a little distributing to do. So 3 times x plus 1 is 3x plus 3 plus 4x. Okay, and so I have 5x times x plus 1 all over 7x plus 3, which doesn't factor, right? So it's all done at that point. So if this is hard to see, particularly that very first step where I distributed the x times x plus 1 through. So let me go back to the original problem here. I had 5 over 3 over x plus 4 over x plus 1. So when I did that distribution of x times x plus 1 in that denominator, okay, we've got 5x. Okay, we got 5x times x plus 1 in the numerator. We're going to leave that alone. In the denominator, what happens here? We've got 3 over x, and we're multiplying that times the x times x plus 1, right? We're distributing that through, like so. And then we've got the 4 over x plus 1, and we're multiplying by x times x plus 1. So that's being distributed to each numerator, right? So what cancels out here? Well, x cancels here, and x plus 1 cancels here, right? So that leaves us with the 5x times x plus 1 over 3 times x plus 1 plus 4x, right? And then we end up getting the same thing that we had before, right? Okay. So I just wanted to highlight that. Sometimes I think writing out that step of actually putting what you're distributing through there into each numerator can be really helpful, and sometimes it can be kind of distracting. So some of you can really just see, okay, well, if I'm going to multiply 3 over x times x plus 1, the x's are going to cancel, right? And I'm going to be left with 3 times x plus 1. So if you can see that easily, fine. If you can't, feel free to write it out as I did down below here. Okay. Oh, I just realized I forgot about the domain restrictions on this one. So let's go back up here. We didn't cancel anything out, so I didn't really think about it. But with complex fractions, x can't be 0, right? If we look at the original expression, what were the denominators? X and x plus 1, right? So x can't be 0 and x can't be -1, right? Yeah. Okay. So anything, even if you didn't cancel it out in a complex rational expression, look at the original expression that you were given. If there are denominators, what makes them 0?